Hello everyone, this is Sinead and I'll be disproving the theory that Mars could have had life before. So as you can see over here, could Mars have been habitable in the past? So I used to think that too until I thought of a theory that this is not true. Early in Martian history, the climate was warm enough for potentially habitable lakes and rivers of water to exist. However, roughly 3.6 billion years ago, the climate shifted from being habitable to inhabitable when liquid water disappeared from the surface. So we don't know how it disappeared, but what we're looking at is to disprove this theory, if it was warm enough or not. So here's how we're going to disprove this theory. So we have Paint 3D over here. So I'm just going to add some text over here, and I'm just going to resize this. Okay, I just gotta figure out how to use this. There. So we have today. Now, from what we know, our sun is like 100% of its luminosity today. We'll just have this over here. Oops, wrong color. Okay, there. So we have our sun over here. And then let's just put the orbits. Just as like that. First orbit and second orbit. We'll just be displaying Earth and Mars. So, Earth, as we know, is habitable just because it's in the habitable zone. Okay, there you go. I'll just do like this. Yeah. So we know it has like blue oceans and whatever on its surface, and its things and whatever it has today, it can like support it. And then we have Mars. We'll just do this over here and then there, and then we'll add red, and so there we have Mars, the red planet. So as we all know, it's like completely barren. It doesn't have any life, but it does have water. And which people theorize it's like from billions of years ago, where asteroids, probably like maybe comets with frozen water, collided with it, and then it left all the water, and then probably because of the gravity and whatever, it went onto the poles and they're frozen there. So like the average temperature of Mars is like in the -60s right now. Let's check it. About -81 degrees Fahrenheit. So that's okay, yes, -62 degrees Celsius. So it has an average temperature of -62 degrees. So that's quite a cold, and that's like inhospitable. Maybe you could live on it, but the other things, like, it doesn't allow them to live. All the other conditions on the Mars don't allow us to live on it. But maybe if conditions were like on Earth, but colder, to -60, we could have lived on the warmer parts. As we know, it's on the edge of the habitable zone, kind of like here. And then Earth is at somewhere over here. So this is like how far the habitable zone goes. And then there's Venus, and then there's Mercury. So it's expected. So from what we know, Mars our sun in the past was 25 to 30% dimmer, which means it had less luminosity. And then that also suggests that Earth there was no life yet, but also because it would have been also hotter because of all the asteroids colliding to it. But let's just say it was not hot, and there were no more asteroids. It was like done forming. It would have still been cold. And then can't you say the same for Mars too? Can't you say that it's way colder? Could have been like minus 100 degrees Celsius. Let's put it over here. Oops. Okay, let's just start with the sun. Last time. We'll just put our yellow over here. Say this was dimmer. This was like 3 to 4 billion years ago. So during that time it was dimmer, and that means that everything would have been colder. So the habitable zone would have been shifted instead. So let's put back these orbits. So it's expected that the habitable zone would be somewhere over here to maybe over here. Something like that. Actually, no. More like over here. Yeah, Earth would have been on the edge of the habitable zone, or maybe even farther, which made Earth around the temperature of Mars if it wasn't like bombarded by asteroids and was done forming back then. So as I'm saying, this is what the habitable zone would have been, because basically if the sun's luminosity is reduced, the habitable zone would have shifted closer. And then we have Mars over here. Okay, I'll just draw these. Okay. We'll use this. So we have Earth. Okay, this looks like a big blob, but just pretend this is Earth. This is Earth over here, and then we have Mars over here. Mars would have been way out of the habitable zone. Its average temperature would have been below minus 100 degrees Celsius. That's around what Jupiter is today. So this kind of is like the point. If there's anything else, like let's just say it had an atmosphere similar to Earth's and it was enough to like sustain life or whatever. If it was in the habitable zone, it still wouldn't have been enough, because it said that Earth would have been inhospitable or whatever. So that means Mars would have been even more inhospitable, and that means its whole life and whatever, there would have been no chances for life. It would have been like uninhabitable. So that's mainly the thing. Maybe the core would have been hotter, maybe that would have made a difference, but not likely. So here's an example. Let's prove my point by using Universe Sandbox 2. So we have Universe Sandbox 2 over here. So as it said over here on Google Chrome, 25% to 30% dimmer. That was around like 3 to 4 billion years ago. Let's reduce it. 0.7. Basically that's like 30% dimmer. So that makes it less bright. Like, it doesn't matter if it's the same temperature, we're looking at the luminosity. Look at how quick this is decreasing. Okay, maybe they were wrong. Maybe there would have been life possible over here, but on Mars, definitely not. Look at that. It's even decreasing slowly. Just because it's getting so cold. Over here in Antarctica, the temperatures are getting down to minus 110. That's colder than Mars can be. Over here, the red shifts. The red part over here would be indicating like minus 30. That's quite cold. Over here, you would have minus 100. Look at how cold it simply has gotten. Now it's just staying stable at that. Minus 18. Now this is basically a projection of what happened back then. Now we have more Mars. Look at that. Minus 122 degrees. As you can see. That's like impossible for life to survive on. It even goes down to like minus 200 in these spots over here. You see that? It went up to there you go, minus 200. That's the coldest spot, and the hottest spots would be minus 80, which is still too cold for life to survive on. So yeah, maybe like the most toughest life organisms like water bears or whatever, those tardigrade thingies, they could have survived, but it's already too cold for them to even like start like living on, like for them to be created. You would need a habitable planet at first, then they could be tough or whatever, and then they could live on those cold temperatures. But it's already too cold for them to even like be created or whatever. So yeah, that's mostly what I've wanted to prove. Another thing maybe I can show is I can just increase the water. There's a little bit of water just because of the ice caps up here. As you can see, there's a little bit of white. That's basically the frozen water there. So here I'll just increase that water. There. Let's just say that. And then let's give... Alright. Let's give it, let's just say a 0.2 G. This is its magnetic field, because since Earth is bigger, it has like a magnetic sphere of like 0.319 G, I believe. So it should be less because it's less massive. So now we'll change its atmosphere mass. Alright, it's 1 Mars. Let's just change it to 1 Earth. So it's going to be way better, right? Probably not. Maybe the temperature would decrease. Okay, it's not making any difference. But the temperature would probably increase. That's what I meant to say. It would probably increase, and then it would like make the chances like slightly higher, but still too slim for like life to even like exist. Like look, it's still like 0.0%. So yeah, that's what I wanted to prove, that Mars never was habitable back then. Maybe it could have been like to a point like at room temperature when it was just like cooling down from the bombardment, but still it's not enough. It's not going to last long enough. It's just going to quickly cool down in a matter of years or so. So anyways, guys, I hope this was interesting for you guys, and this maybe like proved something, or maybe I've been wrong and there are some other points, but that's what I want to prove. So until the next time, I'll see you guys. Goodbye.